Okay, so let's get started. I'm sure a few people are going to join us later, but also going to get this recorded for people who are not able to attend today. Good afternoon, good morning, Luis. You're in California. Um, so it's a great pleasure to be here today, and especially to have the honor to receive Dr. Luis Rosenberg to talk about the use of swarm intelligence to enhance group decision making. Uh, Luis is a longtime technologist in the field of human-computer interaction. He has first developed AR and VR early in the 90s and doing work with the Air Force Research Laboratory. And later he founded Unanimous AI, and he is now the CEO and Chief Scientist of Unanimous AI. And that was when I actually met Luis for the first time, I think 4 or 5 years ago in a conference here in Boston, right, Luis, the CogSIMA conference, and you were presenting the technology of your company, you were presenting something from our research. Then we got connected 5 years ago, and it's great that we have today the opportunity to have you here in our lab, talk a little about your technology, and more important, not only the technology, but the concept and the framework related to swarm intelligence. There are a lot of applications in healthcare, and it would be really great to listen to you, what you have to say, what the work you have done for this past 10 years on swarm AI, and also to think about how we can apply that technology and those concepts to healthcare. So it's really great to have you here. I'm gonna stop sharing my slides and gonna turn over to you, Luis. But yeah, thank you very much for coming today. We appreciate it. See if you can share your, yeah.
All right, can you see that okay?
Yep, we can.
Great, thanks for having me. I'm Luis Rosenberg, CEO of Unanimous AI. And so today what I'll be talking about is using swarm AI to enhance group decision making. And I just give you a quick outline of what I'll talk about. I'm going to start off with talking about the biology and how it informs the technology. And that's because swarm AI is based on the biological principle of swarm intelligence. It's a technology that amplifies the decision-making accuracy of networked human groups. And so we'll talk about how that works, but then I'll also talk about some validation studies that we've done partnering with various universities over the last few years to show that swarm AI can amplify decision-making accuracy. I'll talk very quickly about some studies we published with MIT, Oxford, Stanford, Cambridge, California State University. I'll also mention that we're always looking to partner with universities to do publishable research, and so I will leave that out there if you see any ideas as I talk about the technology of how it could be used in your world. Some of the applications for swarm AI that are the most common, one is group forecasting, so enabling groups of people to connect together over the internet remotely and make more accurate financial forecasts, sales forecasts, engineering forecasts, political forecasts, and yes, medical forecasts. And I will talk some about that. And then also group decision making. So groups of people doing planning or prioritization or investment decisions or diagnostic decisions. And I'll talk about that as well in the medical space. And I'll talk about an example use. The United Nations uses our technology, swarm AI, to forecast famines around the world, and I'll talk about that example because it's an interesting one, and then open it up to questions. So with that said, let me start out with a controversial statement in the world of AI, namely that people are smart. People are really smart. Everybody listening to me right now has massive amounts of knowledge and wisdom and insight and experience and intuition. And 8 years ago, when we founded Unanimous AI, we really asked this fundamental question, which is how can we best harness and amplify the intelligence of human groups? And we asked that from the context of, can we do better than the typical methods people refer to as wisdom of crowds, which is polling and statistical aggregation. Wisdom of crowds, you're probably familiar with it. It works. People have known about it for over 100 years. But the question that really motivated us as an AI company was to say, is there a better way to harness and amplify the intelligence of groups? And like a lot of teams, we look to nature for inspiration. We asked very early on, well, how does nature do it? And it turns out that nature has evolved optimized methods for amplifying the intelligence of groups. Over hundreds of millions of years of evolution, methods have emerged. What nature does not do, nature does not take votes or polls or surveys. There's no survey monkey in nature. Nature also doesn't analyze big historical data sets. There's no big data and machine learning in nature. What nature does is it forms systems, real-time systems with feedback loops that allow groups to converge on optimal solutions. And biologists refer to this as swarm intelligence. And it's the reason why birds flock and fish school and bees swarm. They are smarter together than alone. In fact, they're so much smarter that biologists often refer to swarms, these groups that work together as systems, as superorganisms. And so here on the image I'm showing is a fish school. Biologists would refer to that as a superorganism, because this school of fish can navigate the ocean and make decisions and live entire lives and successfully. And various species of fish have been around for hundreds of millions of years, very successful. And what's amazing is that as that school of fish navigates the ocean, there's no single fish that's in charge. There's no hierarchy of fish. They are working together, thinking as a system. And they actually do it. And again, it's interesting to think about a school of fish. Thousands of fish, each one has a slightly different view of the world. Each one has slightly different historical experiences. Each one probably has slightly different personality. And yet, when they work together as a system, they can navigate the ocean as a superorganism and survive better than if they were making those decisions on their own. And so with that as context, we asked the question 8 years ago, well, if birds and bees and fish can get smarter in swarms, why can't people do it? And before I answer that, it's worth just taking another step back and saying, well, how smart are swarms? And I want to talk about honeybee swarms because they've been the most studied, and they're actually pretty fascinating how smart they are. And so the image on the screen, that's about 10,000 bees, and they have a really important decision to make. They need to find and select a new home to move into. And this happens every year when a colony of bees outgrows an existing home. They need to find a new home. And so when I say a new home, it could be the hole in a hollow log or the hole in the side of a building. It could be a crawl space in your garage, which happened to me. But the question is, they have to find a home. It sounds, in some sense, like a trivial decision, but it's actually a life or death decision that could impact the survival of this colony for generations. And so how do they do this? They actually do it by sending out hundreds of scout bees that search 30 square miles of area looking for potential sites. And they actually go out there and they find potential sites. They find potential homes, and they bring that information back to the colony. And that's actually the easy part. The hard part is then they need to then pick out of dozens of candidate sites. They need to pick the best possible home site for them to move into. And it turns out this is a complex multivariable problem because honeybees are very discriminating house hunters. When they pick a site, they need to find a home that's large enough to store the honey they need for the winter, that's ventilated well enough to stay cool in the summer, that's insulated well enough to stay warm in the winter, that has an entrance that's small enough to block predators, but large enough to allow lots of bees to go in and out. It has to be waterproof, so it's protected from the rain. It has to be near water for bees to drink. And of course, it has to be well located near many good sources of pollen. This, to pick the best possible site would be a multivariable optimization problem across all these competing constraints. A single bee cannot possibly comprehend this problem, let alone solve it. A single bee has less than 1 million neurons. All of us have over 85 billion neurons. You probably wouldn't want a bee to do house hunting for you. And yet when they work together as a swarm intelligence, they have to solve this problem. And again, to appreciate the magnitude of this problem, a human would struggle to optimize across all these competing constraints and pick the best possible solution. You could extrapolate this not just to house hunting, but if you were the CEO of a company and you were trying to find the best possible location of a new factory, very difficult to pick the best location across all the constraints. If you were a medical team trying to come up with the best treatment plan or best diagnosis, again, these issues come up for people all the time. Honeybees have a legitimately difficult problem to solve. And remarkably, swarm intelligence allows the bees to converge on the optimal solution with over 80% success. And when they don't pick the best solution, they almost always pick the second best solution. And so how do they do it? They do it by forming systems, real-time systems that take in noisy data about the world, process that data, and then put out optimized solutions. And so I know what you're probably thinking. You're thinking, well, these are honeybees, how do they process data? They don't really process data. But they actually really process data, and they do it by vibrating their bodies. Biologists refer to this as a waggle dance, because to humans, it looks like the bees are just dancing, but really they're generating signals that represent their support for the various home sites. And just to appreciate how amazing it is, what the bees are doing in their vibrations is they're encoding the direction and distance to the home site that they prefer, and then they're expressing the magnitude of their preference. And different bees are encoding the different preferences, and then they're basically engaging in what you could think of as a multi-directional tug of war, pushing and pulling, supporting different factions until they find the one solution that they can best agree upon. And it's almost always the optimal solution, which then brings me to this question. Well, if birds and bees and fish can form systems like this, can people form a swarm intelligence? And it turns out that we can with the right technology. And so over the last 8 years, my team at Unanimous AI has been studying natural swarms and developing the algorithms and interfaces that allow humans to form similar swarms online. Of course, we humans can't waggle dance, and so we had to create a different method. And so what you see here on the screen is an artificial swarm. Each of the little yellow magnets you see is controlled by a person. They can be logged in from anywhere around the world. They're all working together to move that glass puck. And in this case, they're making a financial forecast. And they're moving their magnets just using a mouse or a touch screen or a tablet or phone. And they're moving them out to adjust the magnitude and direction of their sentiment in real time. And as they're moving, AI algorithms are watching all of their behaviors and determining how the swarm should move. And so at the highest level, a swarm is a real-time system with the participants acting and reacting and interacting, revealing the strength of their conviction to the underlying algorithms, which then helps the group converge on a solution. Now, a key thing to think about is that what people see, what the users see, is very, very simple. It doesn't require lots of instruction. They're told questions going to appear and you're going to answer as a group. You can control your own little magnet, and that's all you need to know. What the AI sees is a cloud of human behaviors happening in real time. And what the AI is doing is it's looking at each individual's behavior to infer the strength of their conviction, the strength of their confidence, and the types of things that the AI is looking at. And it's looking at it every 250 milliseconds in real time, and it keeps updating its sense of the confidence and conviction of the group. It's looking at how does each user pull? What direction are they pulling? How are they switching between options? When are they switching between options? Are they switching in concession or defiance? Meaning, are they conceding to the group? Are they defying the group? Are they working offensively or defensively against the group converging on a certain option. Or some people will appear to be entrenched in their perspective. Others will appear to be flexible. Some will appear to be flexible, while others will appear to be ambivalent, like they really don't have strong conviction. And so the AI is looking at all these behaviors. There's actually a rich amount of behavior happening. And so our system has been trained by looking at human behaviors over hundreds of thousands of questions that we've asked in the past. And so what the Swarm AI system is doing is it's assessing the human sentiments in real time and finding the combination of the group's conviction, how the group's conviction should be weighted in real time based on their varying levels of confidence. And I'll show lots of examples that make this more clear. But again, just at the highest level, what Swarm AI therefore is it's a networked human group, a group of people who have knowledge and wisdom and insight and experience, and we're going to allow them to form a real-time system where their behaviors are being processed in real time by AI so that they can basically become an artificial expert, and an artificial expert that we can then ask questions to in real time, and they can give us more accurate forecasts, estimations, assessments, decisions, and diagnoses, medical diagnoses, which I will show. And so that's the concept. Let me talk about validation, and then I'll show specifically how the whole process works. But when we first started working on swarm intelligence and Swarm AI, we said, this works for biological systems. It should work for humans. Let's test it. We tested it. We saw good performance, and then we started partnering with universities to do rigorous research to really confirm, does this work? Where does it work? And I'll just talk briefly about a few of the studies. A couple of years ago, we published a study with some researchers at MIT looking at groups of financial traders. And so we connected together small groups of financial traders, about 20 people. They would just log in, connect, and questions would appear where they were asked to forecast the price of gold, the price of oil, and the S&P 500. And they did this every week for 20 consecutive weeks. And then we compared their performance to how they would have done on their own, how they would have done if they just took a vote. So it's a statistical aggregation, and how they perform when they formed a system and converged on an answer. And the results show that we amplified their accuracy in making these financial predictions by 26%. And I'll mention that all these studies, you can go to our website and you can download the papers there if you're interested. We did another study with Stanford Medical School. It was funded by NSF, and we published this a couple of years ago, where we looked at groups of doctors, radiologists, and they were asked to diagnose chest X-rays alone or as individuals or as a swarm intelligence. And the way this would work is a chest X-ray would pop up on their screen, and then they were asked to predict what's the probability that this patient has pneumonia. And what the study found was that when they worked together as a swarm, we reduced their diagnostic errors by 33% as compared to if they were just taking a vote. And I should mention that these were small groups. These were 5 radiologists working together as a swarm. And again, it's real time. So the X-ray popped up on all those screens at the same time, and then they forecast the probability, and they reduced the errors by 33%. There was just a group at UCSF Medical School just a few months ago published a study where they essentially replicated this work using Swarm AI, but instead of chest X-rays, they were using MRIs of the knee with assessing knee injury, and they saw actually almost identical results. They reduced the errors by 36%, so slightly better, but again, very, very similar. And so it was very interesting to see the results replicated in a different medical procedure. So far, I've been talking about groups that are experts, like financial traders, radiologists. We did a study with some researchers at Oxford looking at just sports fans, regular sports fans, asking them to predict soccer games. This was in the UK, so it was English Premier League soccer. And they were asked to predict 50 consecutive soccer games, and the results came out with the individuals were 55% accurate in predicting on their own. And that actually doesn't sound that good, but in soccer, they could end in a tie. So win, lose, tie, 55% accurate meant that these were, reasonably good soccer fans who could make predictions. If we just took their predictions as a vote, they did better, 58%. So there's, we always see, this wisdom of crowds happen. But when they work together as a swarm, as a system, they jumped up to 72% accurate, and they actually outperformed the odds makers, the Vegas bookmakers in predicting these games. And then we also published a study about a year ago with California Polytechnic, where they looked at business teams, small teams of 5 to 7 people, and they had 60 business teams, and they gave them a standard subjective judgment test. And across 60 teams, which is a really large scale study, they saw that when the individuals took this subjective judgment test alone, they got a certain score. When they did it as a group by taking a vote, they did a little better, 9% better. When they worked together as a swarm, I reduced their errors by 52%. So again, really big improvements when we connect groups together in real time as a swarm. Now there's a constraint, which is it's a real time process. The groups have to log in at the same time, but there is a big benefit. And so I want to go back to the Stanford radiology study, because there was an interesting follow-up to this study, which was that Stanford, we also compared it to just straight machine learning, which is interesting because in radiology, the big issue is that radiologists are just getting replaced by people. People are just getting replaced by machine learning, where you can just train a machine learning system on hundreds of thousands of images, and it can then process without people. And so we did this comparison. It was, and I should say this actually shows what it looked like when we ran this study with Stanford. X-ray would pop up on their screen, and then it would the swarm, which only had 5 people, said, what's the probability a patient has pneumonia? And then once it does a course prediction, it actually zooms in, and you can get very fine positioning of probability. And that's an example where it was 80%. But so again, we did this with hundreds of X-rays, and then they compared those same X-rays to a machine learning system that just did it with algorithms, no humans. And it was a pretty interesting study. And so humans versus machine learning, it was swarms of 5 doctors versus what was called the ChexNet system developed by Stanford, a machine learning system. And it was just binary classification of pneumonia. Does the patient have pneumonia or not? And what we saw was actually 2 really interesting things. The first thing was that the swarm of doctors did better than the machine learning. So machine learning is in orange, the swarm of 5 doctors was in blue. And so it was a 22% accuracy increase. And that's interesting, but it's maybe not interesting from a medical perspective, because the machine learning is faster and it's cheaper. And if you need to get 5 doctors to make a diagnosis, that's not necessarily an efficient thing. It's not necessarily a thing that insurance companies want to do, even if the accuracy is a little better. And so this was interesting, but it didn't point us in a direction and say that, oh, this is how we should diagnose X-rays. And machine learning keeps getting better anyway. The more interesting thing about this study, and it's on our website, was that the 2 methods actually were good in very different ways. And so they had different strengths. The machine learning system was really strong when it saw cases that were very similar to the hundreds of thousands that it had seen in the past. And so it knew if it saw something that had good alignment with its huge data set, the machine learning system was very good. The humans outperformed substantially on cases that were different, that were unusual, that didn't fit well with what would have been this huge database. And so we then looked at the data and said, well, what if this was actually done differently? It was done as a triage kind of system, where first you process by machine learning, you would and you would take the answer from the cases that were confident. But when the machine learning system realized it had low confidence, you then passed it on to this swarm of doctors and had the doctors then diagnosed by swarm. When we did it that way, we saw a combined accuracy of 93%. So we're able to get to really high accuracy in a more efficient manner, basically use the machine learning for what machines were good at, but use humans for what humans are good at. Humans are amazing at extrapolating with very limited information on things that was never seen before. And that's why we need human doctors, and we'll always need human doctors, even when machine learning gets better. And so that was the medical example. Let me talk about how groups actually do this. How do groups swarm in practice? And so talk about another fun example. We take on challenges from journalists all the time. And for a few years in a row, we took on challenges from Newsweek to predict the Oscars. And it's a fun example to show how it actually works. And so in this case, what we did to predict the Oscars, we found 50 people just on the internet who are just movie fans, not experts. And we invited them into Swarm. All anyone needs is just a standard browser. They get invited by an email or text or a calendar link, just like getting invited to a Zoom meeting. And it's synchronous, so they have to click on the meeting at the same time. And when they do, they enter a platform that looks like this. There's an area where the group can chat. And that's really because there's usually a moderator who's going to ask the questions, and the moderator will say, hey, today we're going to be diagnosing chest x-rays, or today we're going to be predicting the Oscars. And there's an area where you can share media, images, video. There's an area where you can see who the participants are. And then there's the swarming area, which is where really the prediction happens. Usually people just zoom in on that and it looks something like this. And so in practice, what happens is the moderator would ask a question. That question would appear on everybody's screen at the same time, which is most likely to win Best Picture. A set of answer options appear on everybody's screen at the same time. In this case, the choices for Best Picture. Each person can control a magnet with their mouse or touch screen. They move their magnet next to the puck. The closer their magnet is to the puck, the stronger they can pull. So it's actually, they have to be engaged the entire time. Meaning if the puck starts moving away from them, they have to chase it with the magnet. And so we're ensured that everybody is constantly deliberating. And so this is what it looks like with 50 people basically interacting in real time. There's AI algorithms watching all of their behaviors, determining at every moment in time how the puck should move as they deliberate. And so here you can see that they converge on Shape of Water. And again, we did that for all of the major categories. We gave the predictions to Newsweek. They published the predictions, and then we have a lot of pressure and hope that this swarm did well. And in this case, they did. And so how did they do? In this case, they were 94% accurate in predicting the Oscars, just with 50 movie fans. They did better than Variety, LA Times, Vanity Fair, which used movie critics to make their predictions. They did better than Gold Derby. Gold Derby is a crowdsourcing site that gets votes from hundreds of thousands of people. And again, which is a reasonable method, but it's not, it still generally doesn't do as well. It's just a swarm of a smaller group of people. We compared to Bovada, which is a Vegas betting market, and then a Rolling Stone. And so, again, why does it work so well? I want to revisit this one point, which is to really convey how this is a system. So again, at the front end, everybody is interacting in real time. It's very straightforward and simple. In the back end, the AI is watching everybody's behaviors in real time and determining how the swarm should move. But it's a system. And by system, I mean, if you think about it time step by time step, question appears and everybody starts to behave. As soon as they start to behave, the AI looks at all the behaviors and determines which way the swarm should move. But as soon as the swarm starts moving, everybody reacts. They change their behavior. And as soon as they change their behavior, the AI looks at their changed behaviors and determines and updates which direction the swarm should move. And so what happens is the people are influencing the AI is influencing the people, and the system is moving, and it will find the path usually to the answer that the group can best agree upon based on their different levels of confidence and conviction. Again, some people might have very high confidence. Some people might have very low confidence. They might have high confidence with respect to some of those options and low confidence with respect to others. And so the AI is looking at all that and helping the group find this solution. And so with that said, in terms of real world applications, we see a lot of really interesting ones, allowing groups of people to make good forecasts, decisions, evaluations, predictions, prioritizations, assessments, comparisons, insights, really anything where a group of people has knowledge and wisdom and insight, and we want to harness that. we tend to see kind of two different categories: internal teams and external teams. Internal teams could be a group of doctors making a diagnosis. It could be sales teams, marketing teams, engineering teams, executive teams. External teams could be it could be a group of external customers or distributors or analysts or patients. We do work with pharmaceutical companies where they want to understand the attitudes of patients, or they want to understand a patient's reaction to certain products or procedures. And so they can come in and you can get these optimized insights. Lots of major organizations using Swarm. I want to talk about the United Nations because they allow us to talk about it, whereas most companies don't really allow us to talk about it. But the United Nations also has a really interesting application, which is they use Swarm to predict famines around the world. And so it's a part of the United Nations called the Food and Agricultural Organization. They have a group of experts they call the IPC, which assesses food insecurity risk of various nations. And they do it nation by nation. And it's an important assessment where they're going to predict over the next 18 months, what's the likelihood that a certain nation will have food insecurity risk. And the way they do this is they have a team of 20 or a little over 20 people. And what's interesting is that these people can be located in countries all around the world. They have very different expertise. Some are experts in the climate of different areas. Some are experts in the economics of different areas. Some are experts in the politics of different areas. So you have these very different disciplines that all would go into a good decision. Their typical way of doing it would have been to get these group of people together in a room or over video chat and just argue about it, which is difficult, especially when people have different disciplines, different expertise. Same thing in medicine. If you had a group of doctors making a treatment plan and they all have different expertise, different perspectives. In this case, what they were asked to do is assess on a scale of 1 to 5 the risk from food abundance to likely famine. And the United Nations actually first did a 1-year pilot study. Now they're just using it, they're past the pilot study. But the first pilot study was to compare Swarm to their traditional method. And the traditional method was to get people together and basically discuss until they could reach a decision. What they found with Swarm was that they reached a very similar results as their traditional process with greater efficiency, meaning they reached these answers much faster, but also greater satisfaction. And part of the reason is that in a swarm, everybody's equal and everybody's anonymous, which means you tend to have less conflict, less politics. The United Nations decisions actually have a lot of politics. In a lot of businesses, there's just hierarchy. And so people are not willing to express their opinions. They're trying to second guess what their boss thinks. They have different factions, marketing versus engineering. When everybody's equal and everybody's anonymous, they can actually reach decisions and people can actually express their true opinions. And the other really interesting thing is that we find greater buy-in, meaning the participants at the end have greater support for the results, even if they didn't initially agree. And we interview people to try to understand that. And what we find is that if you were just taking a vote, then people give their vote into a black box and then an answer comes back. And if it wasn't what they thought, they think, well, I guess nobody cared what I had to say. Whereas in a swarm, you're experiencing the whole negotiation in real time. You're experiencing it and you appreciate why the group reached the answer it did. And you end up even if you originally disagreed, you feel like you have more stake in the answer and you have greater buy-in. I want to give another example, just because it's a different approach, which we call collaborative ranking, and it comes up a lot in a lot of different contexts, which is to take a group of items and rank them, to prioritize them from most important to least important, or most likely to least likely. We see this in medical, if you're trying to prioritize treatment options, but we also see it in business. And so this example was done, was forecast. It was work with a large clothing retailer, that an S&P 500 company, and they did this test where they wanted to say, can they predict holiday sales of a group of women's sweaters, and do that with a swarm. And the idea was, well, if they could predict in advance accurately, which sweaters will sell more and which will sell less, they could prepare the correct inventory and correct volumes. And this test was done with just 45 people. So 3 groups of 15 fashion conscious women. They were just selected over the internet. So it was not these weren't experts. These were basically customers. And the business goal was to predict the best sellers and the worst sellers and to compare to a traditional survey, because the traditional way to do this would have been to survey 1,000 people and make their predictions that way. And so the way this rank forecasting works is, okay, we have these sweaters, and typically we do this as a process of elimination. And so here, instead of saying which is going to sell the most, we're going to say which of these is going to sell the fewest, and then we're going to remove that one, and then ask the swarm again, which is going to sell the fewest, and remove that one, and you'll end up with this this process, which I'll just show a couple of steps in. So here, which is going to sell the fewest, and here we can see the group is basically negotiating or deliberating, converged on sweater F, and then again, you could see the behavioral data. In this case, what we're going to do is we're going to say, let's remove sweater F and then ask again. And so here we're asking the question again. And you see here the groups deliberating between E and D. And again, we're going to go through this process, which is going to sell the fewest, sell the fewest until we get to the top 2, and then we'll say which is going to sell the most. And we use this rank deliberation process. We've used it in the medical space for groups that are developing medical products, and they want to prioritize, what are the most important features. We've used it with pharmaceutical companies, actually, when they're trying to predict the outcome of clinical trials and are predicting what are the biggest risks. And we do this. You could almost imagine almost every business scenario. The ability to rank things accurately is super valuable. And so, so that gets removed. And so the question is, well, what did the results look like? The goal was to rank, first to 8th. And this is what it looked like. And what I'll point out here is that when we get a ranking, it's not just an ordinal ranking, 1, 2, 3, but we actually can get what we call a scaled ranking, because we're capturing not just the answer, but all that behavioral data. So we know, using all that internal behavioral data, we can then say, yeah, sweater C was ranked the highest, A and B were then ranked next, but they were pretty close. And then it jumped down. So you get this really nice ranking. And then the question is, well, how did the group do? And so the nice thing is that this was a study where they actually tracked the actual sales during the holiday season. And what they found was that the 2 top sweaters sold 1.8 million, where the bottom 2 sweaters sold about 600,000. So there was good high-level ranking. And then we compared that to the survey that they ran. And the interesting thing was that when they did this just as a traditional survey, they actually really did not see discrimination between in how they ranked. And what we saw was that the top 4 chosen by the swarm actually outperformed by 24% more sales than the top 4 chosen by the survey. And we see this again and again, which is that a swarm really does, it allows you to use a smaller group of people, but it also forces the people to be active participants. It forces the people to evaluate their opinion and reevaluate their opinion and reevaluate their opinion in real time. Whereas a survey, you're just asking them to throw a piece of information in the dark. And there's lots of reasons why surveys just are not as strong as swarms. But one of the biggest ones is that everybody's forecasting scale is different. Meaning, when you take a survey and you aggregate, you're assuming you're assuming everybody's confidence is equal, and in fact, everybody's confidence is not equal. And if you have a group of 8 items, somebody might be really confident in a couple of the items, but really be unclear about another, and you have no idea about the relative confidence. But in a swarm, you're actually evoking all this relative confidence information in real time, and you get these really good aggregations. And so, in closing thoughts, Swarm AI. It's a process we start with a networked human group with knowledge and wisdom and insight. You connect them together in real time so they form a system, and you can produce these more accurate forecasts and estimations and decisions and diagnoses. And you get these other interesting intangibles, which is in addition to, to optimizing how you combine the knowledge and wisdom of groups, and you can speed deliberation, getting faster assessments, and then you reduce these social barriers when you have groups, personality barriers. When groups sit around and deliberate, strong personalities overpower weak personalities, internal politics of a decision could get in the way, internal corporate hierarchy get in the way. When you make everybody equal and anonymous, it actually makes, it frees everybody up to really express and think about just what they think, as opposed to what they think other people think they should think. And again, it promotes buy-in. So that's Swarm AI. Happy to take questions.
Thank you very much, Louis. Really fascinating. I'm going to open here for questions because I already asked a lot of questions for you before. So let's see. Anyone has questions, comments? Chuck?
Yeah, it's brilliant. I mean, really amazing. I'm just trying to think of how one could implement something like this in a practical way in medicine. And I think one of the major problems in medicine is the hierarchy and the inability for people within the hierarchy to either voice an opinion or accept an opinion. And but in second to second situation, I'm an emergency physician. I'm just trying to think how one could institute this in a way that would be useful. And for decisions about whether you have pneumonia or whether you have a brain tumor, you have time to sort of do that sort of thing. How does one use this technology or this system to work in a much more temporally constrained process?
Yeah, no, it's a great question, and it's the big constraint is that it's synchronous, and so you need people to work together at the same time. If you do have a group of people who need to weigh in on a decision, this is the type of thing that could be done on a mobile phone or on a tablet, could be done very quickly. Sending a question out to a group who are decision makers and need to then come back and respond very quickly and allow you to get a better decision. But it's every context is different. I mean, in this case, you want to make sure that all the participants are knowledgeable as well of all the situation. So, and it could even be that people are in the same room having a discussion. In fact, when the United Nations uses Swarm, they'll first have a conversation. They'll have a conversation about the answer. They'll swarm. Then they'll have another conversation about what the answer was, and then they'll swarm again. So that if the answer that they reached, if somebody feels like the answer was reached because the group didn't understand something or they didn't appreciate something, like, oh, you gave Haiti this this risk because you didn't think about that, they can express that, and the group can swarm again, and it might influence the answer, it might not influence the answer. But for high stakes decisions, that's actually a pretty good process. You could imagine the same thing in medicine.
It's interesting, Louis, that we do a lot of work in team training, where we get groups of people in a unexpected, low frequency, high acuity event. How do we get them? My philosophy is the answer is almost always in the room. It just doesn't always get to the patient. And how do we get that answer to the patient? It's what's obstructing it, and most often it's ego, it's hierarchy, and what we try to do is we try to level that hierarchy. And I'm not sure that's the absolute answer. I mean, clearly it's multifactorial, but that's what we're trying to do in real time, is to say the attending might not know the answer, and the nursing student might know the answer, and it doesn't matter. The patient doesn't care whether it's the nursing student or the attending physician. And those are the types of things that we're working on in sort of contemporaneous team training. And it's really neat stuff. I really, this was fascinating.
An interesting thing is when we did that study with Stanford, where we had small groups of radiologists, just 5 radiologists, we were, our biggest worry was that these were all experts. I mean, these were experienced doctors. All the doctors were either at Stanford or Duke. I think there was one other site. They were experienced doctors. They were affiliated with top medical school. They were people who know what they're doing. And so you would think, like, are they going to get any benefit by swarming? But when they start to swarm, it forces them to open their mind and say, oh, I really thought this patient had pneumonia, but like other people don't. Like, what am I missing? And again, if people were anonymous, and again, it would be really interesting if it was a group of experts and residents, and so you didn't know who was who, you didn't know if they've been doing this for 30 years or 5 years, and everybody was anonymous. You might get the same kind of benefit where people start to might wonder, like, what am I missing? And it just changes the mindset, changes their mentality, because everybody's anonymous, so you don't know who's who. The group is just, let's just reach the best answer, as opposed to, I want to show I'm the smartest person in the room.
Absolutely, yeah. And I see like a lot of, and as you mentioned, right, one thing is like a lot of applications, a lot of like decision making happen, the clinical practice, right, like the diagnosis you show. Another one, I mean, think about the second opinion programs, right? So it's very like gray areas for knee replacement or spine surgery, right? And the recommendation, okay, you go to the second surgeon, get their opinion, but then at the end, it's up to the patient to wait 2 expert opinions, right? If you have something like this that you put like 4 experts, then to decide if the patient will benefit from like spine or surgery or like knee replacement, right? Maybe if you show here the same pattern, that will be better related to better decisions, right? In terms of like complications and all that stuff. So that's another application.
It reminds me a lot of the cancer boards.
Yeah.
Where they get, where in the tumor boards, where they'll get, radiologists and radiation therapists, radiation oncologists, and the medical oncologists and the surgical oncologists, and they'll come together and have a discussion about a case. And I'm sure this, and I don't know the data, but I'm sure there's data that shows under those circumstances there's probably higher accuracy, and it would be even higher, I would bet, if it was anonymous.
Yep.
If it had even bigger numbers and had more diversity. It's just cool stuff. Really, I'm fascinated by it.
Now, the other aspect that we tried, like a few years ago, to do a pilot study, but then a lot of the grants came and we didn't have like enough time, but it's for assessment, competence assessment, right? A huge problem we have nowadays is how to assess competence of a physician, health profession, right? We have this like self-assessment, that's terrible. We have, expert observation, that the inter-rater reliability is not good. So one of the things we're trying, Chuck, at the time is like, how can we show a video and get a group of experts to swarm and decide the non-technical skills rating instead of trying to do an average across 4, right? That also, I think, could have a good application for assessment, medical education assessment.
Thank you very much. It was an amazing concept and I really enjoyed. I have a question. So it's a great application and it comes from like getting consensus. So my question here is that when it comes to having equal vote, how the algorithm deal with equal vote, because this is one of the most challenging parts of the decision making. People make a decision, vote on something, and then they got equal things on doing this or that, selecting A or B, and how this decision making happens in this situation.
You're saying, are you talking about if the people are treated equally, or if you're saying if it's a binary decision, A or B?
The people are equal and selecting, for example, for A and for B.
Okay, got it. So so the issue is, does the group get stuck, right? Does the group get stuck? One thing I didn't mention is that we put a time limit on every question. it's 60 seconds. So when the question shows up, they have 60 seconds to reach an answer. If they don't reach an answer in 60 seconds, the time runs out, and actually it comes up and it says brain freeze, which is the case that you give, which is they couldn't reach an answer. When we first developed the system, we expected that to happen all the time. It almost never happens. It's very, very rare for the group to just be unable to reach an answer. And part of it is we tend to ask questions in a way where we give a range of options. So if I was going to ask, like we do a lot of sports forecasting, and so if I was going to ask who's going to win the Yankees or the Red Sox, right? I won't just ask A or B. I'll actually give 4 choices, which is Yankees low confidence, Yankees high confidence, Red Sox low confidence, Red Sox high confidence. And so you get this spectrum of behaviors, and so you're forcing people to reveal their behaviors, and it allows. And when you do that, you almost never have the group just stagnate. They will converge on an answer. The only time we see it is if we ask a really politically divisive question where people are just so entrenched that they're just unwilling to consider anything. But outside of that, it doesn't happen. Now, they might run out of the 60 seconds. If so, we'll ask again. And it might be that we have to word the question slightly differently, like it was poorly worded and people were they were interpreting it differently, but it's a far more rare process.
Thank you very much. Amazing concepts.
Hey, Luis, I have another question that based on all your research with the Swarm AI, did you notice, for example, if the people who start with less confidence, they switch their position more often towards the group or not, or something like that? What is the behavior of the less confident people?
Yeah, so the people who are, there's a lot of people who have very little confidence will concede right away to the perspective of the group. If who have high confidence will not. And the thing is, like, if you could ask a set of questions, and some people will have high confidence in some questions and weak confidence in other questions. And it actually goes down to this question, well, what makes a good participant? We say a good participant is well calibrated, meaning they know what they know and they know what they don't know. The best participants know when to not be confident and know when to be confident. The worst participants are people who just think they always know. And we actually did a study, a really interesting study with Marist University that does the Marist poll, and they do a lot of polling. And they said, let's predict sports, and we'll compare 2 groups, just regular sports fans and sports writers. Now, sports writers make a living on thinking they always know the answer. They are more entrenched. Sports fans actually better calibrated. They know what they know. They don't know what they don't know. And the sports fans actually were much better at forecasting in a swarm than the sports writers. And in fact, the sports writers actually have an extra thing that works against them, which is they've trained themselves to always pick the unusual outcome, because it's not interesting to just write the most likely thing that's going to happen. And so sometimes experts are really not the best. That said, in every medical study we've done, medical experts are really well calibrated. That's the thing. Like a good doctor knows when to be confident, knows when not to be confident, and when they work together in a swarm, they actually work very well together.
Yeah. Until you start doing this with residents, because then you have that transition between low confidence and overconfidence. But that's interesting, because a lot of the things you're mentioning here, I'm trying to map this, try to understand if the artificial swarm has the same type of cognitive bias as individual humans, right? Overconfidence bias, confirmation bias, you just go towards like that, or like going with the others, right? All these are like individual cognitive bias that probably in certain extent will also be present in the swarm, right?
So yeah, biases will exist. Part of it goes to how we ask the question. The biggest problem that like if I'm doing sports forecasting, if you are a Red Sox fan and I ask you who's going to win, I'm asking you to predict who's going to win, and you might be telling me who you want to win, right? Like that. And so we really very careful in how we word the question, but also because we're asking the question in this context, we're getting groups to think objectively. We're saying, we'll ask, what's the probability? Like, what's the probability that the Red Sox win? And we'll use a large enough group where, it will be, we'll have people from across the country. It still could just be 50 people, but we have a group of people from across the country that would neutralize that particular bias. People are people. There are, these biases happen, but when you start to aggregate, the biases start to cancel out in opposite directions, and so it.
You should do a study where you ask that question with just Red Sox fans and just Yankees fans.
Yep.
And see what happens. I bet is that you'll get disparate.
Yep.
Answers or results.
Yeah.
Really
and
cool.
It is, and we do that in politics a lot, where we'll ask groups, conservative and liberal groups ask the same question. And then we actually have ways we can aggregate the data so they can participate either together or apart, and then we could aggregate to understand really how the sentiments converge.
Yeah, that's great. Yeah, so thank you very much. It was really exciting to see your presentation and how the Swarm AI intelligence could be applicable for many areas of decision making, right? Of course, with some limitations in more like emergent situations, but I see a lot of situations, especially med education, that it could be used to, as you mentioned, to enhance our accuracy in decisions, clinical decisions and education decisions. So thank you very much. We appreciate.
Can I ask just a quick naive question? AI in this case, is that artificial intelligence or augmented intelligence?
So you can look at it a lot of different ways. I mean, we're taking human intelligence and we're amplifying it. We do use traditional AI, but that traditional AI is looking at the human behaviors. It's not looking at the content. So if I have a group of financial analysts, typical approach to AI would be forget the human analysts. Let's just do machine learning on financial data. What we're saying is, well, no, we do machine learning on human behaviors to understand sentiment. We don't have to know anything about the financial data. As long as the people are human, our system will work. But what we're using traditional AI, but we are using it to amplify the intelligence of human groups. And so it is definitely this hybrid approach that combines human intelligence and machine intelligence. And it's really about reforming a system. But yeah, it's, it goes back to the first slide I said, which is, we start from the perspective that, people are smart. And a lot of machine learning, a lot of AI research is just willing to throw the people out right away when, there's knowledge and wisdom and insight and experience really. So the other thing I'll say it again, which is if anybody has ideas for projects, you want to collaborate on some research using Swarm, we're always looking to do studies because there's so many interesting ways to use the technology, especially in medicine, where the decisions are high stake, and like you said, some of the decisions are also high pressure, time pressure, and high stakes. So
yeah, absolutely. Sounds great. Yeah, thank you very much, Luis. Again, really appreciate it. It's great talk.
Great talk.
Yeah, thanks.
Thank you.
Thank you, everyone.
Very
Bye.
much.
Bye.